GLM-5.3 is the model everyone is talking about. And here's the thing you should know up front. The base model underneath is exactly the same as GLM-5.2. Same 743 billion parameters. Same architecture. Same mixture of experts' design. The version bump comes from retuned weights and better training data, not a bigger brain. That is a genuinely important shift in how AI releases work. We used to measure progress by raw size. Now the frontier is being pushed by smarter training, not just more parameters. In this video, we will break down what open weights actually means, why bigger is not always better, how a 743 billion parameter model can still run cheap, and whether that 5 trillion parameter rumor about OpenAI and Anthropic holds up. By the end, you will know exactly what to look for the next time a new model drops. So what is a weight? Really? Think of a neural network as a web of connections between layers of nodes. Every connection has a number attached to it, and that number is the weight. It decides how strongly one node's signal influences the next. When the model is trained, those weights get adjusted over and over, nudged in the direction that makes the output more correct. The entire knowledge of the model, everything it knows about language, is stored in these numbers. There is no separate database of facts. It is all baked into the weights. Now here is the key distinction. Closed models like GPT and Claude keep those weights secret, locked inside a server you can only reach through an API. Open weights means the actual numbers are published, so anyone can download them, run them on their own hardware, fine-tune them, and build on top of them. That is the difference between renting a model and owning it. GLM 5.3 is open weights, which is a big part of why it is getting so much attention. Does bigger always mean better? Mostly with a caveat. Within the same architecture, more parameters means more capacity, and for a long time the industry treated that as a law. But the capability curve is not a straight line, it flattens. Past a certain point, doubling the model size buys you a smaller and smaller gain in actual ability. Meanwhile, the cost curve does the opposite. It explodes. Training a model twice as big costs more than twice as much, and running it at inference time gets slower and more expensive for every single request. So there is a real trade-off. The smart move is not to chase the biggest number. It is to find the point where you get the most capability per dollar. That is exactly what GLM 5.3 is doing. Instead of scaling up the total size, it is squeezing more out of the same 743 billion parameters with better training and better routing. That is the modern playbook, and it is why the headline parameter count matters less than it used to. Here is the trick that makes a 743 billion parameter model practical. It is called mixture of experts. The model is not one giant network that uses all of its parameters for every single word. It is split into many smaller expert networks, plus a router that decides which experts to activate for each token. When you send a prompt, only a small slice of the model actually does the work. For GLM 5.3, that active slice is around 40 billion parameters, even though the total is 743 billion. The rest of the experts stay dormant, ready to be called on when the input needs them. This is a huge efficiency win. You get the knowledge and the capacity of a massive model, but you only pay the compute cost of a much smaller one. That is why a model this size can still respond quickly and run affordably. Mixture of experts is not new, but it has become the standard architecture for frontier models, and it is the reason the raw parameter count is no longer the number that matters most. Now, let us talk about the rumor that keeps floating around. There are claims that OpenAI is working on a 10 trillion parameter model, and that Anthropic is building a 5 trillion parameter opus. These numbers get thrown around a lot, but here's the thing. None of them are confirmed. They are speculation, leaks, and educated guesses dressed up as facts. And even if they were true, the whole point of this video is that raw parameter count is not the whole story. A 10 trillion parameter model that is poorly trained could easily lose to a smaller model that is trained better. So when you see a headline about a 5 trillion parameter model, treat it with skepticism. Ask what the active parameter count is, ask what the training data looks like, and ask what the actual benchmarks show. The size of the model is a marketing number. The performance is what matters. GLM-5.3 is a reminder that the frontier is being pushed by efficiency and training quality, not just by who can build the biggest network. So here is the bottom line. First, bigger is usually smarter, but only all else being equal, and the gains shrink fast as models grow. Second, what you actually pay for is the active parameter count, not the total. That is what mixture of experts is all about. And third, the 5 trillion parameter rumor is exactly that, a rumor unconfirmed and disputed. The real story of GLM-5.3 is that it is the same 743 billion parameter model as 5.2, made better through retuned weights and smarter training. That is the direction the whole industry is heading. Progress is no longer just about building bigger networks. It is about getting more out of the ones we already have. So the next time a new model drops, do not just look at the parameter count. Look at the active parameters, the training data, and the real benchmarks. That is where the truth is. Thanks for watching. And if this helped you understand open weights a little better, hit subscribe.
Why do Chinese labs give their best models away? It's not charity. Start with the constraint. US export controls cut them off from advanced NVIDIA chips, so they can't outbuy their way up the scaling curve. That forced a culture of efficiency, mixture of experts, distillation, squeezing frontier capability out of far fewer chips. Now the open release is the strategy. Give the weights away and you become the default standard. Developers build on QN, DeepSeek, GLM, tune them, deploy them, and the whole ecosystem accrues to China. The money comes later, through cloud hosting and enterprise services. Open release is customer acquisition, not philanthropy. It also reshapes geopolitics. China positions itself as the open counterweight to America's closed models, and it undercuts the pricing of every closed model. When a 743 billion parameter model runs for free, it's hard to charge a premium. So an efficiency born of a chip embargo became the sharpest competitive weapon in the field.